My name is Sanjeev Kulkarni, and I work with AWS, and I lead the business strategy for product engineering and R&D for automotive industry. It's an honor to present this session, and it's an honor to have with me co-presenters Tara Wacher from Stellantis, Kevin Bocki from AWS Auto Industry Team, and Henrik Schoenberg, who's from AWS ProServe. We will be very thrilled to present this session, and we'll take you through this in the next 60 minutes. So just a brief agenda. I'll start the session, give an overview of what is this domain that we are going to cover today, the exciting domain of product engineering, R&D, and what do we mean by the total scope of this particular domain, the challenges, the opportunities to transform this particular domain. After that, Tara will cover a very exciting customer success story of Stellantis Engineering Workbench, and we'll show you what they have accomplished through this. After that, Kevin will come on board, and he will cover what the path forward looks like for this domain for AWS and our partners. And then, Henrik will also join, in between to cover the Stellantis technical aspects of the Stellantis Workbench. And then we'll be, after that, available to do any Q&A. We'll make ourselves available after the session. What is the excitement about the automotive development toolchain? And what do we mean by this? Today, we live in a very exciting time frame. We are all surrounded by innovations in every aspect of our life. At the same time, auto industry is at the forefront of bringing all these innovations to us as the end consumers through their products, through their services, and through the experience. At the same time, auto industry is going through significant transformation, driven by business and the consumer trends. For example, connected mobility or software-defined vehicle. These are increasing, and the electrification, these are increasing the software content in the vehicle and the complexity that it adds to the product. At the same time, the consumers are asking for personalization and mass customization. That adds to the complexity of the product as well as the business. And these particular things are adding significant change and demands on the product innovation domain. What we mean by product innovation domain and the process that is used by product innovation is kind of defined in the middle that you see here in the gray color. That's no new news for anybody. This is the process that every automotive company leverages, going from planning all the way through development, all the way to the end of life, going through manufacturing, sales, service, and other domains. This particular process is followed by most companies, and behind and leveraging this process is thousands of people who are working across multiple functions and multiple organizations that are making this innovation possible. This is the total domain and the stakeholders that we would like to try to address through this session and make their lives a little bit easier and more efficient, more effective, as well as rewarding. If we take a deep dive into this particular overall value chain, end-to-end value chain, you'll see there are many, many subdomains. And typically, people think about product engineering as product planning to product development, validation, and definition of the manufacturing process. But for us, we are realizing that there is an interdependency from the core function of engineering with respect to the product planning upfront, and then the downstream consumption of the engineering information in the areas of manufacturing, sales, services, and end of life. This is the total scope that we are looking at, and all the tools, very niche tools and processes that are used, that is the total tool chain that AWS is looking at and what can we do, how we can improve it, how we can modernize it, and how we can make it more efficient and effective. At the same time, it's very important to look at the feedback from all the downstream processes back into the engineering so that we can do the lessons learned, we can look at knowledge capture, and try to improve the engineering processes at any given time, and as well as on the long time scale for the future vehicle programs or future activities. And this is the total tool chain that we are interested in looking at. And again, when we look at this tool chain, we find some interesting challenges that our customers are facing. We have used AWS working backwards approach and talked to various lead customers, try to understand what are the key challenges that customers face. And the key challenges can be summed up in 3 categories. Typically, this entire domain, most of the stakeholders, these are cross-functional stakeholders, and they use tools that are like, if tens or if not hundreds, very specialized tools and digital techniques that have been provided to them. The access to these tools at appropriate time for all the stakeholders and making sure that they have these particular tools available as and when needed in the context of innovation decision they're supporting is very critical. It's not always easy. Many times people spend a lot of time to get access to these tools. Having an environment where people can get access to these tools is very important to the people. It's not only the environment, but the environment needs to be scalable and should provide the performance that they're looking for so that they can do their work efficiently and effectively. The other challenge is also that the information connectivity that is needed across all of these tool chains is very, very important for them to carry out their functions effectively. And the third challenge that people mention is they need to have a collaborative environment where people can collaborate across functions and across organizations in a very secure and very well-governed environment. These are the 3 challenges that we are intending to address, and we want to make sure that we take care of our stakeholders to make their lives better. With the knowledge of these key challenges, we have defined our solutions. And our solutions are defined on 3 key pillars. Our solutions are what we provide between AWS and our partner network. The key challenges that we would like to bring, our key solution pillars that we would like to leverage, are the digital product twin. Please keep in mind that what we mean by product twin is not just the product itself, but the product as well as the resources, the processes that are leveraged in this entire innovation domain. We would like to provide capabilities to create high-fidelity digital twins on a common environment. This is what we are looking at providing, and this is what we are providing with the help of our partners, a vast network of partners throughout the entire value chain. In addition to that, the next key challenge that we are hearing from all the customers, and we are trying to address it, is through the digital development thread. The digital development thread provides the connectivity across all the tools, as when the tools are from various different vendors, they have different formats. Independent of who provides the tool, which format it is in, providing an information connectivity across them is the key pillar of our next solution area. And given the digital twin and digital thread, what this enables, along with the cloud infrastructure, is an ability to provide an innovation network that brings various stakeholders, the people across various functions and across various organizations, provides them a common environment, a common place to come together and collaborate in a digital environment while providing security and governance so that the IP that they are working on, the IP that is being productized, developed for productization, they can collaborate with the appropriate information as well as have the intelligence that is needed to make some decisions for driving the innovation. These are the main pillars of the solutions that we're bringing for the development tool chain and to transform the entire domain. One such example, just to highlight the need for innovation network and what can be done, is in the area of E&E development in the automotive. As I mentioned, the increase of software content in the vehicle is putting a lot of emphasis on E&E development, where software, the ECUs, they need to be developed, and there is a lot of collaboration that is required across the software development, the hardware development teams, being able to provide them development capabilities as well as the validation capabilities is very critical, and provide them a common environment as needed and when it is needed so that they can collaborate and they can have a common environment to do that particular work is extremely important. That is the power and that is the vision of the innovation network. To talk about how this has been accomplished at Stellantis through their virtual engineering workbench, I would like to welcome Tara Wachter from Stellantis, and she will take you through the details of the whole presentation. Thank you, Tara.
Thank you, Sanjeev. Good evening, everybody. It's very bright up here. So I'm Tara Wachter. I lead software architecture and development for Stellantis for the new platforms. And I'm going to cover a little bit about us. So Stellantis actually was formed in 2021, the beginning of 2021, and is the combination of two highly successful and experienced organizations. Both organizations actually had a very iconic brands, and both of them were really working towards the same initiatives. But as we formed the organization, we've now really pushed to accelerate kind of our evolution towards software and connected services. So most people don't typically know the name Stellantis, but you do, oftentimes people will know the brands. And so this is why we share the brands here. So some of the ones that you might know would be Jeep, Fiat, Maserati, Ram, the Peugeots, Alfa Romeos. But you can see from this slide quite a complex overall portfolio. Now what we want to talk about here is, so there are various collaboration efforts with Amazon, but the one we want to focus on here is the one in the lower corner that's highlighted, and that is about the Amazon Workbench that Sanjeev had mentioned. So I'm just going to go to the next slide here. So when we look at our goals and what our challenges are, so I kind of mentioned the brands and I mentioned a little bit about the complexity. Our key strategy is actually around 3 tech platforms. Tech platforms that will disconnect software cycles from hardware cycles in our development. Also ensuring that we can develop and provide the capability of some of the features that our customers desire. And then also using artificial intelligence in order to predict and to provide better advanced automotive systems. So these are the 3 tech platforms that we talk about: the Stella Brain, Stella AutoDrive, and Stella Smart Cockpit. And along with that, we have 4 vehicle platforms that each one of these will support. So what you really see here then is, on the left-hand side, you see the vehicle platforms, and each one of them will have and be built on these 3 tech platforms. But what are our challenges as we look at that? So we talk about those 14 brands, and we know each one of these that there will be this increasing complexity. So one thing I didn't exactly say, but Stellantis is an extremely global organization. And there's many different developers in 5 research and development centers. But each one of these have core software developers that need to be working together and need to be working collaboratively. The time it takes for developers to get onboarded quickly is a challenge, absolutely a challenge. Ensuring that they're working in the same environment, ensuring that they have the right hardware available in order for them to test and ensure the quality of their artifacts that they're delivering is a challenge. And ensuring that they have the ability to validate all of the levels that they need to before they actually commit their software. So why did we partner with AWS in order to do this workbench? So the way we look at this is Stellantis provides the automotive domain knowledge, and we understand what our software development workflow is. But AWS provides the cloud technology and the framework in order for us to learn and to develop with. They also provide and have the culture of innovation that we can work with. So together, we feel that this is a very synergistic approach, and it's definitely something that we're learning from each other and we're developing together in order to provide the ideal solution. So today, oftentimes, so we talk a little bit about our physical workbenches, which is very typical in the automotive industry today, and how we're working with our vehicles, how we're doing our testing, how we're integrating with our devices. And what the virtual workbench does is exactly that. It ensures that all developers are working again in the same environment, but it also provides a virtual environment so you don't need to necessarily rely on the hardware that needs to be available at any given time. Obviously you want that, but I mean initially, so as we shift things more towards the left-hand side of our development cycle, we have the ability in order to do as much development ahead of time and as much validation ahead of time. It ensures that the developers have the right environment and they have the right configuration, that no matter where you're working, no matter what region you're working, you have a consistent and a collaborative environment to work on. So with that, I'm going to hand it over to Hendrik, and he is going to cover a little bit more.
Thank you, Tara. Hi, everyone. My name is Hendrik Schöneberg. I'm a principal data architect for AWS Professional Services based in Zurich in Switzerland. And I'm really excited to be here and to tell you a little bit more details about the virtual engineering workbench that we built for Stellantis. And we heard from Tara, so the Workbench initiative's idea is really to transform automotive software development from the physical world to the virtual world, to the cloud world. And when we started the project, we wanted to really make sure that we address all of the core challenges that we heard about from Tara before. So we heard that these are the common challenges, and we used our AWS working backwards methodology to really identify solution tenets that then drive the design of the platform. So looking at the challenges, we arrived at this first tenet, and this is self-service. We really wanted to make sure that we cover the fast onboarding and the quick enablement of users of the platform. If you think of onboarding of people onto your team or for your use case, this typically involves many, many different stakeholders. There's automated, and there's manual processes to it. There's different departments. You have stops in there. You need approvals. There's software to be procured. There's hardware to be procured. And even after all of that is done, you're not ready yet. So depending on your role or the use case that you want to work in, you would then have to configure your software environment. You have to have your runtime environment configured. There's licensing involved, these kind of things. So all of that can take time, and we learned from Stellantis that this can easily take up to weeks or even months. So the one first tenet that we derived from this challenge was we really wanted to make sure that no matter what you do on the platform, you're empowered to do this fully in a fully self-service manner, and you're ready to go for your use case in a minute or like in minutes. Going to the next tenet, so we were looking at global scale. We also heard from Tara before, Stellantis is a very, it's a global organization. There's thousands or 10,000s of users to be onboarded. This is not only internal users, we're also talking about partners and suppliers. And it should not matter from where you access the platform, no matter what region you're in, you should always have the same user experience that once onboarded, you have access to your resources and can get started within minutes. So due to Stellantis' heterogeneous network topologies, this, of course, is a challenge, and we wanted to really make sure that this is covered with the platform. Then, in order to facilitate the shift from the physical world to the virtual world, we really have to also reduce the hardware dependency. So right now, ultimately, we're, of course, developing software which at some point is running on an ECU somewhere in a car. So we need to test and integrate on physical devices, and these physical devices have limited availability in numbers. And if you're a tester or integrator, you would have to schedule your time on that device. So if you really want to remove this bottleneck, we have to instead work with virtual targets or abstractions from exactly that target that you want to work on. So this is the next tenet that we wanted to build in, and using the virtual workbench, we include virtual targets that represent the target architecture of the platform that you want to build for. And then all of that, of course, is growing the complexity by a lot. So you do not only have the typical software engineering challenges, you have the different levels of abstractions of your targets, you have the testing and the integration, and on top of that, you have to be also compliant with functional safety regulations. So all of that creates a very, very complex picture, and this is why the fourth tenet that we derived was we wanted to be consistent and reproducible on the platform. So now that we have the solution tenets in place, this helped us guide the solution design of the platform that we actually wanted to build. So in a nutshell, the Stellantis Virtual Engineering Workbench consists of three main pillars, and that is tools, targets, and environments. We manage that on the platform, and the interface to the user is a self-service portal. So you get access to these three categories from a self-service portal that empowers you to do things in a fully automated manner. All of that is underpinned by full end-to-end automation. That means all of these software artifacts, everything that gets created is covered by use case-specific automation. And we'll get more specific in a second. Maybe starting with the tools. Under the tools umbrella, we cover everything that enables you to get started in your use case. So no matter if you are a VECU developer, in that case, you might be looking for a runtime environment that contains AUTOSAR Classic, all of the tools configured, the IDEs in there, licensing already covered, configured in a way that you can start it, or if you're an integrator or a tester maybe. So under tools, you would find predefined use case-specific environments. Under targets, as we heard before, so we will have different abstractions of the target platform that we're building for. So the ultimate goal is that we're having software that at some point is working on an ECU or is working on a car, so on an actual physical device. And we will work with having various levels of abstraction in the platform. And of course, I was thrilled also to hear the announcement that now QNX has as a product on AWS that we can use as a target here in that workbench. Last but not least, as a third category, we have the environment. And the environment basically is the input that we give to the workloads on the targets to verify their function. So these also come in different levels of abstraction. So similar to the target, you might want to test an ADAS camera, maybe in the beginning with synthetic data. At the end of your, with increasing maturity of your product, you want to expose it then to real world data. So there's also, there we have different levels of abstraction or fidelity. To give you specific examples of how this would look like, here's one example. If you are, for instance, paying software for an ADAS camera, you might be using, as a toolbox, you would use an AUTOSAR Classic development environment, and the physical target for that is the ADAS camera. So you have your virtual targets that abstract from that, and then your inputs to that, so the environment for that workload, would be an ADAS simulation or could be synthetic scene data. To give a different example, if you wanted to develop, let's say, an entertainment system, the stack would be different. So for a developer aiming to develop software for an entertainment system, you would use a different toolbox, and that is housing the QNX development environment. As a target, you might then, in this case, opt for the QNX AMI that is available. And as an input, you would choose synthetic user input or maybe actual user input that was recorded. So we are almost done with the conceptual level, I promise. I just need to shortly introduce another level of complexity. As we heard from Tara before, so there's growing complexity in the cars, and we have seen there's easily 150 ECUs sitting in a car. And what that means is these ECUs, of course, do not work in isolation. So to give you one example, if you have an advanced feature in your car, like, for example, the emergency brake assist function. So the emergency brake assist function, just to name one, would be realized you have an ADAS camera that is recording a field. And then if it detects an event, maybe a dangerous road situation, this would trigger a response to the braking and to the power steering ECUs. So you have ECUs working together to form a feature. So this is a complex interaction. And in order to develop something like that in the physical world, the approach is clear there. But we also need to find a way of shifting that to the cloud and finding a representation there. So how would that happen using the Workbench approach? So with the ADAS camera target in mind, A VECU developer for that target would spin up a AUT203 classic or adaptive workbench, use that to develop, use that to work, and then this would ultimately trigger a commit. So an artifact would be created, and then the automated end-to-end pipeline would pick up that commit, would build, would test, would promote the artifact, and as a result of that, you get a validated VECU artifact. So you know at the end of this pipeline that you have a VECU artifact which is ready to be used and ready to be integrated. But the problem is, in the physical EE architecture, we have multiple ECUs that are integrated with each other. So they need to talk to each other. There's an integration going on. So in parallel to the ADAS camera, we also need to, in the virtual world, then develop VECU artifacts for the braking ECU and for the power steering ECU. So in parallel, a different developer, a different team might be developing those VECU artifacts, and then we need to find a way of integrating them in the cloud as well. So this is then the next level of complexity that we're talking about. So we'll have an integration plane there, where we integrate the different VECU artifacts and embed them on virtual targets, physical targets, or a mix of them. So not only the integration adds the complexity, but the integration with various levels of abstraction of the virtual targets for your physical target in the end. All right, now from the conceptual level to the implementation level. So how do we actually implement this? Let's start with the first few tenets to cover them. So here again, we're looking at self-service and speed of onboarding. So the self-service portal is really the interface for the global user base of Stellantis. The user base is completely distributed. We have different regions and locations, and we have to make sure that for everyone the user experience is the same and everything is secure. So therefore, the front end is completely integrated with Stellantis identity provider. So that means as soon as you have an identity with Stellantis IDP, you would be able to be onboarded onto the virtual engineering platform. Regardless of if you're an internal developer, partner, or supplier, you can be onboarded to the platform, given a role, and get access to its functionality. So once onboarded to the front end, you have then access to pre-configured products on the platform. So these products constitute workbenches, the toolbox, the virtual environments, and the user inputs. And these are configured using AWS Service Catalog. So we are pre-configuring runtime environments exactly with a tool set specifically for a use case. And these are then selectable from the service catalog from the user interface. We also pre-configure use case-specific pipelines. And in our case, these pipelines are run on Team City because we wanted to make sure that we integrate with the pre-existing, very strong skill set of Stellantis on-prem CI/CD capabilities. And these CI/CD pipelines then use the virtual targets to execute their build steps in. Just to give you also a quick overview how that would look like from a user perspective. So now that you have seen how the self-service portal works, how would that look like from the user perspective or the user journey? So there's two fundamental flows from the user perspective. So the first one is the persona of the virtual engineering workbench contributor. So the contributor's role is to package the products that are available in Service Catalog. And so we are looking at the runtime environments with the tools, the automated pipelines, and the software or hardware targets. Each of these categories of products are wrapped into CloudFormation templates, added to a portfolio, and then are added to the AWS Service Catalog. These are then rolled out and form the VEW product catalog. Here we switch personas, so we're now looking at the VEW user. So depending on your role, if you're a tester, integrator, developer, partner, supplier, you have access to different product categories on the platform, but you would use the self-service portal to gain access to the catalog that was built by the contributors. Here you can select and browse the products. You would take the one that allows you to do your job, you would deploy it and start doing your work. In this case, you would see the example down there. So you have the user interface. There's a selection of components and products in there. You would select the one that is relevant for your use case, deploy it. In this case, it could be maybe an AUT203 classic development environment and start working. Your work ultimately results in a commit, or it creates an artifact, and this artifact will then be picked up by use case-specific pipelines that create an output. All right, back to the implementation level. So the second, the second set of tenets that we wanted to cover in this case are the self-service and the complexity and consistency. So we wanted to make sure that whatever happens on the pipeline, on the Workbench is fully versioned, and there's full transparency end-to-end and full end-to-end automation. Using the different stacks of tools, the environments, having the virtual engineering, the virtual targets, all of the different components integrate with each other creates a lot of complexity, and the only way to overcome that is by fully automating everything. So the first thing that we did is if we have new product releases or security patches or there's deprecation of tools, this would create a new product in the service catalog. This would then be automatically rolled out by AWS Service Catalog and EC2 Image Builder. So using those two services, this would then be distributed to the user's accounts from which they can then select and use them. We also have fully end-to-end created automated pipelines. These pipelines then would use these products created in the catalog, and that makes sure that whatever you create, so which software artifact you choose, even if it's a VECU, if it's a test report, if it's an integration result, all of that is fully covered by pipelines, and you can reproduce the results and make sure that you have end-to-end transparency on all of the products that have been created. Last but not least, we wanted to make sure that no matter where in the world you're connecting from, that you have access to all the critical services on Stellantis side. So as a developer from your virtual engineering workbench, you need access to, let's say, licensing service, you need access to central resources like GitHub, like the Artifactory, and we are connecting to Stellantis on-premises network through Direct Connect. And this is, of course, a challenge because due to the large organizational footprint, the global layout, and the different network topologies, consolidating that was done using AWS Direct Connect. We also wanted to make sure that we do not only stay in the virtual realm. So while we want to achieve a shift from the physical world to the virtual world, we also want to make sure that pre-existing on-premises hardware like devices or hills can still be used, of course. So these are represented as products in the service catalog as well, and you can use them as targets for your pipelines to be run on. Then this ensures that you have access, no matter if you're a supplier or partner or internal developer, to the virtual engineering platform. All right, with this insight in how we built the platform, I'm happy to hand over to Tara for a quick summary.
Thanks, Hendrik. So we just wanted to close out this session here with identifying what then the benefits have been. I think we've kind of mentioned that, both myself and Hendrik. Managing complexity, number one. The fast enablement of developers. So currently, right now, we have over 1,000 developers using this Workbench. Faster time to market, because now we can actually ensure that we have the right environment, the right consistency overall, and that's consistency and compliancy. So we've talked a lot about these different elements, but we're not completely there yet. We're sort of in the process of this, right? So we've been working with Amazon, and we still have some work to do. So what have we deployed so far? The features that we have right now then is the integration and the virtual workbench development with suppliers and partners. So not only is the internal development teams using this, but we actually have everybody who's developing software for Stellantis is using this Workbench, and we make sure that everybody is on board in that same configuration. We have here 100 developers. It's actually thousands of developers globally have been onboarded today. So in all of our R&D centers, we have them all onboarded. Initial Workbench catalog and self-services are fully deployed. So this is actually in place today as well. So the UI that Hendrik had talked about, that is there available, so it's very easy to use. And then some of the first deployment for testing and integration use cases have already been deployed as well. So still some work to do there. What we're going to be looking at then in the next several months is to continue our efforts, but now really focusing on the virtualization portion of this and making sure that we get the VECUs in place so the testers can really start doing their virtual testing and ensuring there's a correlation to some of the physical test environments that exist. Continue to scale the overall developers so again, we talked about thousands, but obviously there's several thousands of developers that we really need to make sure we get on board. And again, including both internal as well as external. And then obviously more to come, right? So we will continue this partnership and continue this overall engagement with AWS. I will now hand it off to Kevin to close out the session. Kevin.
Well, thank you very much, Tara and Hendrik. You can see now why this particular case was so important to us. In the product engineering, the product development, R&D space that Sanjeev and I are working on, this, in the software and the electrical electronic systems development, this is really addressing, the heart of where a lot of the innovation is coming from in automotive at the moment. What I want to do is I want to take that and I want to zoom out a little bit and give a bit of a glimpse on what other topics are we looking at from a product engineering, product development workload. I'm the solution strategy lead working with Sanjeev, who handles the overall strategy for this particular space. So really happy to walk you through this. If you remember right with Sanjeev, he had highlighted 3 different pillars that we were really centering our innovation around. The first one being the product twins, the digital twins. The second being the thread or the continuity between those twins. And then finally, the third one being the innovation network, which is really bringing the people and the organizations together so that you can accelerate innovation. Now, when we talked with customers, as Hendrik said, the working backwards approach, talking with lead customers at the OEMs and Tier 1 level, and we looked at what they were really focusing in on, it boiled down to 6 kind of areas that we were prioritizing. And they really fit pretty nicely into those 3 pillar areas. So if you look at the first side, the product twins. So smart simulation and validation, we do a lot in the HPC and the compute side for CAE, computer-aided engineering workloads. But one of the things that we're really looking at on that is how do we expand the value? How do we gain insights from that analysis and simulation? And even more importantly, how do we bend the cost curve down on the validation curve? Because we still have a lot of physical prototype and physical testing going on. So the promise of computer-aided engineering was always that we would be able to correlate and we would start to offload some of the physical testing into virtual and CAE and focus our physical prototype and testing on those that warrant it. So smart simulation and validation is about that, gaining those insights, running the simulations, doing the correlation, managing the data, and ultimately bending the overall cost curve on the validation process. The next one in there is the engineering modernization. So a big activity that our customers are looking at is taking the PLM environments, and the Stellantis case is amazing in the area of electrical electronic systems and software development. But there are a lot of development activities going on in the traditional systems, body, chassis, restraints, the traditional infotainment systems, body electronics, closures, and so on. All of those are still being developed and still innovating. And they're innovating on PLM environments that are largely, getting long in the tooth, right? So they're not able to capture some of the services and capabilities that we're offering in AWS. So a big piece is engineering modernization and getting a path to value and taking those environments and moving them into AWS cloud to capture the value there. Now, if we look at the digital development thread, as Sanjeev had talked about, that's really about connecting those twins together. So as Sanjeev mentioned, twins are going to be our twins, your twins, partner twins, right? But ultimately, we have to put them into action by connecting them together, enabling some new use cases, and improving existing use cases by eliminating a lot of the manual labor. Now, I'm going to be talking about that in a little bit more detail in the Design for X section. But intelligent requirements, this is a key area again. In the systems engineering space and even in the upfront product planning, there's still a lot of manual effort and a lot of I'll call it non-intelligent use of requirements that are guiding the direction. So a big piece that we want to be able to handle is connecting the different requirements together with the artifacts that are delivering against those requirements, so then the validation can be performed and we can better improve over time. Now again, in the Digital Innovation Network, going over to the third one, I'm going to be talking about the Innovation Network and Marketplace, but I want to talk here about engineering release. So another big activity that we found a lot of manual effort, a lot of manual work going on is as we're preparing and refining and designing our solutions through the product development process, being able to translate that in the automotive space over for execution is very difficult because of the complexity in the automotive space. In the OEMs, large tier ones, they're dealing with massive amounts of complexity that have to be translated into execution. There's another ripe area for us to go after. So zooming in. So if we look at that design for X, what do we mean by that? So core to automotive engineering has always been, how do we take something from product planning? How do we translate into an as-designed view? How do we communicate that off to manufacturing effectively? And a decade ago or so, I'll age myself, but a decade ago, that was pretty much where we stopped, right? Kind of got into some service and so on, but that was really where we stopped. Now, it's all the way into service and ultimately into end of life, and then all the way back into the beginning cycle and the planning. That horizontal thread, right, and continuity has been core for product engineering and automotive. However, if you really look at the processes and how that's managed, it's still largely manual going between those different areas, right? We may establish connections or traceability, but it's manually or actively created rather than passively through the product development process. So we want to be able to address that. We can use AWS and cloud to be able to address or make that a simpler solution and a more passive automated solution. Now, one that gets missed in this particular design for X piece is another dimension. So now what we have is customers are really looking at better decision support, not just from the functional, the form, fit pieces, but also the business. So how can we bring more business data, related data like cost and so on, assessing risks, things that we're feeding from the downstream processes from the vehicle in use to be able to make better business decisions about the innovations that we're doing. So there's two dimensions that we're looking at there and leveraging. Now the next piece that I had mentioned was the innovation network. This is really why we were excited on the virtual engineering workbench, because if you look at what was done there and the key tenets that they were accomplishing and that they accomplished with that, it was really aligned to both the digital twin in terms of connecting the right tools together, the continuity and the connection between those tools, right? Bring the tools to bear, connect them together. And then ultimately, also, if you look at the tenets, it had the network effect, right? It was about doing the self-service aspect that was mentioned as well as global connection. So this really fit well as an illustration of what Innovation Network is about. Now, like I said, that is a particular functional scope. What we see is expanding that out to many use cases, regardless of what kind of design process. It could be in battery, it could be in EV, it could be in ADAS development, it could be in core body in white development. All of the different development activities involve people coming together with the right tools, creating the chain of those tools, basically connecting them together, and then bringing the people and organizations in so that they can accelerate innovation. Now, benefits-wise, we talk a lot about the core cloud values. If you talk to anybody at AWS, they're going to be able to recite all the core cloud values and bringing your tool chains and your solutions onto AWS cloud. What we're really here from the workload in the product engineering space with Sanjeev and myself and others is really about building upon those and accelerating those values in the area of this domain in product engineering, meaning time to release, right? A big factor in value and so on is going to be, can I more effectively release on time, right, and be predictable about it? And one thing in automotive, and I kind of laugh with this, is we hear, well, we want to keep getting the development time down to, down, fewer months. in reality, when we see this, it's about predictability, right? If you can just be predictable about your releases and the efforts that you're putting in there, that's a huge value, right, for program engineers. Innovation pipeline. So with additional capacity, which is the third one, if we can unlock capacity from the R&D organization, then obviously we can go after more innovation, and we can increase the innovation pipeline into product development. That is a huge business value, top line value. And then finally, quality, iteration, and rework. So these are kind of core, fundamental pieces, right? So we want to be able to increase the frequency of iteration, right? But we want to decrease the need for the iteration, meaning we want those iterations to be more effective. That's where bringing more intelligence, more data, and you've heard this throughout the sessions at reInvent, right? That data is key. So we leverage that data to make our iterations more valuable so that we can increase frequency, but more importantly, increase the effectiveness of those iterations. That's a big tenet for us. It impacts the entire downstream effort. Right? So these are kind of the acceleration values on top of the core values that we typically talk about in AWS Cloud. So again, that was a glimpse. Gives you kind of a very high-level view of some of the key topic areas. We'd be very interested in talking with you if any of those resonate. I want to thank our presenters, Sanjeev, Tara, Hendrik, for bringing in this amazing case.